Hi everyone, welcome back to the channel. And today we're going to solve Leetcode daily challenge, problem number 211, design, add, and search ports data structure. So this problem is basically, an extension of the try search or try logic which we do. So in try, basically we look for a substring in an array of string, you can say. Okay, so it makes your search of a substring much more efficient than just traversing the whole array and looking for the substring in each individual let's say word. Okay. So this is exactly, the exact implementation of try. And to know more about that, in I think yesterday or day before yesterday, I made a video on that as well. So I'll link that at the top, so you can check that out as well. And let's move to towards solving this problem. So we have to basically fill or complete the given class word dictionary. So there'll be three main functions. First one will be init, in which we'll initialize the object which we are going to use. Second will be addWord, in which you will add the given word into the try. And third one will be search, which will basically return true if your string is in the try and false if it is not there. There is one more interesting addition to this. The dot, like the strings which we get for uh, get to search, can have dot, and this dot can be interpreted as any letter. Okay. For example, we have T dot A. Okay. So it can be TEA, or some other letter between that. So this is the complete question. Let's see what we have to do, and let's just move towards the solution. I'll explain you what we'll be doing in the coding part. Okay. So first things first, I want to define a new class which will basically have the structure of my prefix tree or try in it. Okay. So what I'll be expecting in this is I'll have children, which will store all the children nodes or all the child nodes, which will have your letters. For example, in let's say T. Okay, so T will have E, then A, and so on and so forth. And last one is self-taught is completed. So this will basically represent if at this particular node the any of the word which I have seen got finished or not. For example, in T, the word will end at A, right? So this flag will be true for A, but for E and T, it's gonna be false only. Okay, so we done this. Next comes the turn of word dictionary. In here, I first want to initialize my root. Okay, this will be the starting point of our try or prefix tree. Okay. Next is addWord. It is really simple implementation. You just have to iterate this complete word, and you have to take reference of your current prefix tree or try, and you will add the character if it is not already there in the path which you are following. If yes, it is, then you'll just skip that character or letter. So currently we are at self.root. Okay. Next, we will iterate for char in word, for individual character in the word. If char not in current node dot children, then only we will add that current dot children char, and we will initialize it to the node. Okay, and we will also increment our current node as well. Okay, so current will become current dot children and that. And once we iterate the complete word, wherever our current node or current header is, we will set the is completed flag as true. Is completed as true. Okay, so this was a really simple function to complete. Next comes the interesting part, in which you have to implement a search. Okay. So I hope you remember that dot condition where that dot can be anything, any character in it. So to tackle that specifically, I would use a DFS approach. Okay. And what I'll do, I will define an helper function called DFS, and I'll provide in two variables, index and node. Okay. Index will basically represent the current index or the index from which you want to look in, and node will basically represent your current node. Okay. So first things is I want to run a loop in range index till length of the word we have received to look length of word. Okay. And what I want to do, I want to look for an individual character at index I. Okay. Now here comes two conditions. So if your character is dot, then you want to follow one path, else there will be another segment. Okay. So what you'll do if your character is a dot, in that case, basically you will be calling the DFS, and this is the primary reason why we have defined an DFS in it. So for this, what I'll do, I'll just use all the children for our current node. Okay, so node was the current node we have or we were at. So we will use all the children of the current node, and we will check if any one of those condition or path satisfies the uh, the later characters or the later words which later characters or letters which we were looking at. Okay. Yes. Okay. If yes, then I will just simply return true from it. Else, if you are not able to, find a path ahead after dot, we will just return false. Okay. Next comes the else part, where if you check if your character is not in node dot children, then you will just simply return a false. Otherwise, you will move your where it is node, your current node to node dot children, and you will pick the char. And at the end, if you were able to reach to the last node where any of your already seen word or added word got complete, you will return that. And this is it. Like I think the helper function is also done. And at the last, we will just initialize the DFS with zero and self dot root. Let's check out the test cases quickly. So the test case got accepted. Let's submit for further evaluation. Okay, it is taking some time. I just hope it doesn't give us time. Okay, so the solution got accepted, and I would say we performed decent. We have performed 32.82% of the summary solution. So yeah, thanks some guys for watching out the video, and stay tuned for the upcoming ones. Don't forget to subscribe to the channel. Thank you.